As part of the system and collaboration, we need to be making sure that you can use these systems for the class and collaborate with us. All communication is being done with Piazza. You should have received a link from Canvas to enroll in Piazza. Please do this now. All announcements and interaction is being fostered through Piazza, and you need to be making sure that you are enrolled and see our announcements. We will be doing online lessons with Zoom. And the link to Zoom is clearly posted on the web page, on our class web page. Please revisit it and use them. We also will be using GitHub, so it will be requiring you to create a GitHub account. In certain circumstances, we sometimes use also Google tools, such as Google Hangout and Remote Desktop. Next, we go a little bit into our systems. And we have a variety of systems that we will be using. Future systems will be one of them. This is our own cloud. And we will actually use probably 2 clouds in that. And we would be very interested in... but we also would like to alert you that from Windows, you need to have SSH access to these systems. And you will have to explore how to do this. PuTTY is a typical one. However, the new features in Windows 10 will allow you to directly go from the PowerShell or the command shell into systems, and you will have a Linux-like environment on Windows. However, that's not sufficient because Ansible is not supported on Windows, so you will be still needing to use Ansible within a virtual machine in case you were to use Windows. There will be special lessons being posted on some of them. Some we don't actually need to have lessons because this thing is just too easy, like for example using of Emacs, VI or Nano as editors. We will introduce you however to virtualenv and PyP, how to install from PyP packages with pip. We introduce you to package managers such as apt-get on Ubuntu. And we will be teaching you somewhat advanced SSH features, such as SSH config and SSH tunnel. However, our cloud mesh does already a lot of the SSH mechanisms in the background, so you probably will have a very easy time to connect to the virtual machines on remote cloud resources. And this leads us directly into that a lot of stuff that we are doing in the class practical activities as part of the project is being done in OpenStack. However, you're also able to use Amazon Web Services or Azure. However, you need to be paying for those yourself, while the OpenStack clouds are free to you. And as for private clouds, we will probably not allow you to use any of the private clouds that you have access to, because we want to do an open source project and you need to be sharing your activities with everybody in class so that we can reproduce them. We will be therefore using also a hybrid cloud management with Cloud Mesh, and this allows you to start virtual machines easily on any one of the 3 clouds that we operate. It's also possible to integrate Amazon and Azure in Cloud Mesh, so you could be using this to start up virtual clusters. Your mileage may vary. While we have done a lot of support in OpenStack, we have somewhat a lesser support in Amazon and Azure. We will naturally introduce you to some concepts such as automation and orchestration as used in DevOps. We will be using Ansible. If time allows, we can also talk about SaltStack, Puppet, Chef, and Juju, possibly even OpenStack Heat. But we will be focusing this class on Ansible. This makes it easy on everybody because this is done in Python. You don't have to then yet learn another scripting language, and we stay all in Python. The overall context and relationship of these tools may be discussed, so such as orchestration, collective DevOps, what's, for example, Tosca, how do we do platform as a service, and but we will be focusing really on Cloud Mesh. We will be, as part of Cloud Mesh, teaching you how to stage virtual clusters with a one-line command. So this is really good for you. Instead of spending many hours and weeks to learn this from the ground up, we have actually a one-line command that actually does this. Not only that, we also have a one-line command that states a Hadoop cluster. So instead of you going onto a system where Hadoop may be pre-installed, you will actually install a virtual cluster on which you install Hadoop, and this is being done via our Cloud Mesh software. That Cloud Mesh software uses internally also Ansible, and therefore you will be able to contribute your own Ansible deployment stacks to Cloud Mesh. It's important to give you a showcase, what we will be discussing on the access patterns. Here's an example for how do we do an HPC cloud data intensive cluster, where cores are being shared amongst multiple users represented as part of these gray blobs on here. And what could happen, naturally a user could have a completely separate set of cores, or they could be sharing cores. And the impact of this needs to be carefully thought through, and we need to be doing performance experiments in order to verify if, for example, a sharing could be allowed, or what impact such sharing of resources actually has. Typically when you use Azure or Amazon, such information is not being provided to you. However, you could be, for example, creating reservations where you are not sharing cores with other users in order to exclusively benchmark on such resources. The same is applied in HPC cluster support for HDFS. That's the Hadoop file system, and here you may actually use cores that are directly attached to data, and which may be interacting with an object store. So you will be issuing your queries on a distributed set of data that are associated with cores, and then potentially move the data as part of that result into an object store. We will be talking about hypervisors and containers within the class, and talk about big data projects such as Zookeeper, Storm, Mesos, Spark, and Pig and Hive. And certainly some of them you may or may not want to use as part of your projects. The class is being posted in this particular web link, or everything is hosted on GitHub. This allows you to contribute actually to the web page and get acknowledged from it via your GitHub accounts. And some of the homework are directed towards that you actually actively contribute to this. And we would like to make it a point that instead of you submitting your own homework to just Canvas, we like to make sure that you submit all your homework through GitHub as part of an open source project management infrastructure. This is important because Canvas is naturally not an industry standard, however GitHub is, and the way we are submitting homework is geared towards you learning how to do that. Many of you may already be aware of it, and so you have an easier time to do that, but we will be explaining how to do this. And this is something that is very important when you are trying to apply with companies, that you have that kind of knowledge. A lot of companies look for that knowledge, and if no one will ask you, have you been successfully able to submit your homework to Canvas? So therefore we will be using Canvas as little as possible and do everything through GitHub and scripting environments in order to achieve that learning outcome for you. One of the things that we also do is we offer potentially ungraded homework and lessons. When you go to the class, which I have a separate lecture on, you will see that there are lessons, but they have also some exercises. When we say go to this page and there's an exercise that's not explicitly mentioned in our layout, you don't actually have to do it. You can do it as part of your own self-study so that you can see can I actually replicate what's on that particular page. We will be clearly marking which homework you have to do, and we'll specify this very clearly in Piazza. Our initial homework for you is you need to get the accounts that we have posted online as part of the class. And there's a quiz or survey that you need to be filling out. And in fact, there are two. One quiz is about giving us all your accounts so that we can add you to some of the clouds, and you can be added to our GitHub repositories. And then the other one is I would like you to start working on setting up a machine on which you can start Python 2.7.1 and use virtualenv. That's in many cases, many people have Windows PCs, so I would recommend that you download VirtualBox, install VirtualBox, and install Ubuntu in your VirtualBox, and then use Python 2.7. Actually, it's not 1, but 7.13, I believe, by now. So I will correct this slide later. And you will be all set. You also should be starting to learn about SSH so that you can upload your key to GitHub, because that is needed in order for you to conduct the front homework. With this, I would really thank you once more to choose this particular class. Make sure that you know that there is programming in this particular class, and you will be able to learn really cool stuff as part of the class, because I believe no other class at IU will be letting you use so many different infrastructures and clouds as this particular class. Thank you so much. See you next time.